All right. So the first thing I want to do, I do need to shout out a big thank you. So this was a tremendous amount of effort to put this workshop together. We met every day for the last couple of weeks. A dozen of us or more. People were working on it every day, working through the weekend. Really a ton of effort in making this happen. So really a big thank you to the team to pulling it together. It was really a very much a community effort to make this happen. You got it. Okay, so that said, as I said, there's two things here. There's the logistics page for the access, and then there's the README. So have people made it to the README or made it to the access to the VMs yet? We got one person. All right. So let's start taking a look at that. So the first thing I'll do is explain a little bit about what the environment looks like. That's way too small to see. And you should be able to see this image on your personal laptop as well. But this is what is in your VM. So this area here in the middle is your VM, and it's a complete environment. We've provisioned 4 clusters in here. There's a Nephio management cluster, there's a simulated regional cluster, and there's 2 simulated edge clusters. And we're going to go through the exercise of actually deploying some packages across these different clusters. Those clusters are interconnected with multis, which is necessary for workloads, and we're going to deploy some things. So in this page, which you might want to take time to read later, there's quite a bit of explanation of all of the context. I'll try to talk about some of it as we go, and interrupt me and ask me questions, because this is intended to be a learning experience for everybody. But I think as you use the UI and you sort of step through some of the actual activities, some of the concepts will become more clear, because they're pretty abstract in many ways. All right, so first step, accessing your environment. So I'm assuming we haven't all finished this yet, so I'll explain what we're doing. The first thing we need to do is connect to the machine, and when we do that, we need to forward a port from our local machine to that remote machine, to a local port on that to a port on that remote machine. And then once we're logged in there, we need to forward a port, that same port from that remote machine to the Kubernetes cluster pod running. So it's a double tunnel in order to get access to the UI. Once you do that, you should be able to pull up in your browser localhost 7007, and you should see a UI that looks something like this. So there's a link in, why is my machine not responding? There we go. So after you've run these commands, this one runs on your local laptop, and then this one runs on the machine you've logged into from that local laptop. And then you should be able to follow this link on your local laptop, and you should see a screen like this. So, has anybody successfully done that yet? A couple of people. Okay. So, if you're running into trouble, raise your hand, and somebody can come around, or Vish, or oh, you're helping Tina? Okay. Bala, can you help Kasha right there? So I'll talk a little bit about what we're seeing. Well, if you download the file, you have to rename it to .ssh/Nephio. I should have named it the same thing. That was a mistake. Okay, so I want to talk a little bit about the concept of packages. You'll notice what this menu says is package management. So in Kubernetes, I'm going to talk a little bit about this. we have resources. Resources are just descriptions of something you want in the real world, typically. And then you have controllers. Controllers read in the resources, which state the declared intent, and then they act on the underlying infrastructure or whatever it is to actuate that intent. So this is our intent reconciliation loop. We continuously evaluate what the world looks like, we look at compare it to what we want the world to look like, and we try and resolve it. So Kubernetes has a bunch of built-in types of controllers like pods and deployments and replica sets that you may be familiar with. But Kubernetes also offers an extension point called a custom resource definition that allows you to leverage all the machinery of the Kubernetes API server to follow that same process, but for your own custom types. This is the basis for operators, which we've talked about a little bit here. And an operator is really just a general term for a collection of these controllers and resource definitions and resources that manage a particular type of workload. So it's just a way. The name comes from, it's supposed to be like a human that's babysitting an application. So like if you had a MySQL application you wanted to build, it's not an ordinary, it doesn't work like a web server. It works a little bit different. It's got some special things. So you need a human operator to, for example, go in and quiesce the disk before you do a backup. And so the Kubernetes community years ago came up with this concept of an operator, which is a piece of software that allows you to do operations on top of workloads. Kubernetes by default has two workload control, at least three workload controllers built in. Deployments for stateless things, stateful sets for stateful applications, and daemon sets for per node applications. That's not sufficient for many types of workloads, like the MySQL example I gave, where you have to quiesce the disk. There's special operations you want to do if you want to do those things. So that's the idea of operators. For network functions, you have the same idea. You can have an operator that manages a network function. So we're going to demonstrate, or we're going to talk about two different types of workflows that Nephio will support. And one, I'm sorry, I'm trying to see if I have this described in here, but it may be going out of order a little bit. The one is what we call an operator workflow, where you have an operator running on the edge cluster, and you deliver to it a custom resource that describes the network function you want to run, and it renders the underlying Kubernetes manifests, like the deployment or the stateful set or the config map, that piece of software needs in order to run on Kubernetes. So your management layer, your GitOps layer, which Nephio is all built on GitOps, manages the custom resource, and what gets delivered to the cluster, the edge cluster, is that custom resource. The operator running locally uses that to create a running piece of software on that edge cluster. The other workflow we'll demonstrate, if we get time for it, because there's a lot here to cover, but it can be left as a post-workshop activity, is what we call our shift left. So this is actually my preferred mechanism. The idea is that we don't need an operator. There's disadvantages, both advantages and disadvantages to having an operator on the edge cluster. But instead, beforehand in our management cluster, we can take the package and we can do all of that resource generation up front in storage and just render those basic Kubernetes manifests like deployments and config maps and store them in Git, where you can observe them ahead of time, exactly what's going to run on your cluster. You can run policies and validations against them ahead of time, exactly what's going to run on your cluster. And as we'll see later if we get to it, you can actually manage upgrades to new packages through that and customize it without having to touch the operator. One of the big disadvantages in my mind of the operator pattern, where the operator runs on the edge, is that in order to change any manifest generated by the operator, you actually have to upgrade the operator.
Could you maybe zoom your browser a little bit?
Yeah. Okay. So how are we doing for getting actually environments set up where you can follow along? Is there anybody still having trouble, or what's that? Nothing is on the browser? Okay. Well, call out to the helpers who are out if you need help. Otherwise, we're gonna kind of keep stepping through it. So let's look at the those different workflows I talked about. I'm going to talk a little bit about this. It's not visible. That's not readable. So I mentioned packages. What is a package? A package is just a collection of Kubernetes resources stored in a directory. They're just some files. I can show you one. I'll do this. So here is a package in a Git repository. It's just a set of files, and it has one special file called the kept file, and I'll talk about that in a minute. But these are just ordinary-looking Kubernetes deployments. So that's all I mean by a package. But what we have is this idea of packages evolving through their configuration process. So we track, we have this idea of different Git repositories that represent packages sort of written and owned by different organizational or parts of your organization. So initially we have public catalogs. A public catalog is a Git repository or OCI repository, but we'll just say Git for now. Git repository that contains a bunch of packages. Those might be published by a network function vendor. So a vendor can come along and they can say, I'm a packaged software vendor, I have this. Here's my opinionated version of how you should provision my particular piece of software. So this is very similar to a Helm chart, but conceptually, or how it fits in, but the actual implementation and way it works is quite different. So the vendor pushes that to their public catalog. Oh, I had a better, their public catalog. And then in your organization, you would have your own private catalogs. And this allows you to clone that from the public catalog and keep it in your private catalog and make customizations to it. So maybe you add in some policies, maybe you change the registry to point to your internal registry instead of their public registry. A number of changes like that can happen within your organization. And the UI system here and the underlying APIs support this whole process. So you clone that, and you end up with that in your organizational repository. Then, in fact, internally to your organization, you may have a team that wants to customize that further. They can clone it, make further customizations to it. And then finally, you want to say, I want to deploy that across 100 clusters. So we use an automation to clone that across 100 repositories. And you can make individual changes to those individual clones for each cluster. And the interesting thing is that the entire platform keeps track of how those all fit together, how those all map to one another. Let me, this one's too vertical for the screen here. So that enables us to, we end up with a hierarchy of packages, sort of like this. So the vendor has a package that represents their basic configuration. We make a small change to that as part of, in this case, it's sort of there's an extra tier here. But as part of our organization, we modify it a little bit. Our individual teams modify it, they modify it, and finally you deploy it to a set of clusters. So we have a lot of different repositories going on. And we can actually track so that when the vendor goes and says, oh, I've got a new release, I've got a new image tag, because there's a security vulnerability, they change their package. We can discover now, because we're keeping track of these backlinks to our upstream package, what we cloned it from, we can actually backtrack and say, oh, that means that our organizational blueprint needs to be updated. Blueprint package, same thing. So then we update that. Then that's got a new revision number. So our individual deployments that are based off of that all see that there's a new revision out of there, and they all say, oh, we need to be upgraded, and we can go through and do like a rolling upgrade across all of them. So we managed to keep track of those upstream connections in such a way that we can automatically discover upstream changes, and we can merge them in safely with review and and something I didn't talk a lot about is the structure of packages. Because they're all Kubernetes resources, merges become much simpler. Because it's structured data that we can understand as opposed to like a template, a Helm template, which is just lines. And when you merge just lines, then maybe you break the syntax and the whole thing falls apart. When it's a structured data, you can actually understand that and merge it in an intelligent way. Okay, so are people following along? Are there any questions? Should we jump into the UI and start looking at some of the actual flows? Yes, sir.
You mentioned operators, and it still occurred to me where they fit what they do specifically on this year.
You mentioned what?
Operators.
Operators. Okay.
What they are, I just don't know.
Yeah, good question. Let me see if I've got a good picture for that. Oh, the question was, I've talked about operators, and it's still not clear where they fit. So if we look back, let me show you, I'll try to describe it here. All of this stuff, let me see, I think, make that bigger again. Okay, all of the stuff happening in this top half above here is happening, it's just configuration changes happening getting stored in Git. Nothing's getting applied to the Kubernetes API server. At some point, the Kubernetes things get applied to the Kubernetes API server, and depending on what those things are, that's either all you do, or the native Kubernetes controllers will take over, or an operator that's running at this level will read that. So the idea is that the example we're going to look at specifically is, so Kubernetes natively understands this thing called a deployment and this thing called a config map. In order to run the free 5GC UPF, you need one of each of those. You need a deployment resource that tells you what image to use, what container to put it in, what networks to attach it to, things like that. And you need a config map that tells it its configuration. So in the operator model, rather than what gets pushed directly to the API server being a deployment and a config map, what gets pushed to the Kubernetes API server by this pipeline is what we call a UPF deployment resource, and we'll look at that a little bit later. It's got the information needed to create a UPF, and then there's a piece of code, an operator, running in this cluster that sees that and says, oh, I know what to do with that. I know to create a deployment for that and a config map for that. And I know to annotate the deployment with this network attachment, basically.
This operator also maintained through Forge and all this thing.
You can, yes, we're going to actually deploy it through this UI. So it's just another Kubernetes workload that happens to be part of the, talk to Kubernetes API server. Yes, sir.
It keeps track of the relationships between everything, I guess.
Yes, I mean, Porch will do that, or the Nephio, what will be Nephio one day. By the way, I do have to say, this is all prototype code. Everything you're running here, it's going to break, and there's help things in there on how to clean up your things if it breaks, or you see errors, raise your hand. But I do intend this day to be like the starting point, and after this workshop, we're not going to get through the whole workshop. After the workshop, we'll make available the ability so you can create your own VM with this whole environment, and you can go through these exercises, and we can all work on it and talk about it on Slack or whatever. But yes, that's part of. I mean, operators are specific to a particular type of workload, but then Porch kind of runs at the top level and keeps track of the different packages. So there's two different. I'm not sure which thing you were referring to, but. Does that help clarify it a little bit?
Yeah.
I think it'll get more clear as we go through. Okay, so if you're looking in the description in the README. Where we're going now is we're going to start going through the exercises. So the two journeys we're going to try and get to, but we'll start with the first one. Starting with the UPF, this is the operator workflow. So what we're going to do is we're going to use the UI to create an organizational version. First, we need to deploy the operator. There's no operator running right now for free 5GC. There's just the platform. So we want that operator needs to run in every edge cluster. So the first thing we're going to do is we're going to use something we call a package deployment resource that will allow us to create that operator across multiple clusters. So in order to, but before we do that, we want to create our own internal organizational version of the upstream external catalog package. So to do that, we go onto the screen here, and you'll see these 4 different boxes. Deployments are things running, those are the manifests that actually get applied to the Kubernetes cluster, whereas blueprints here are sort of abstract or not yet fully realized, not yet fully hydrated with all the configuration. They're not for a specific cluster, specific workload. They're a template, sort of. So what we want to do is first create an organizational blueprint. Easiest way is to go here to where it says catalog. This is the catalog repository that's already registered with your system here, and click on that, and you'll see it says add organizational blueprint. So you're going to click that, and we have a few different options. We can create one from scratch. That's if we wanted to write our resources directly from scratch. But what we want to do is actually, we could clone it from another organizational blueprint if we wanted to create some variant of that package. But we want to clone it from an external blueprint. Registered in your environment are 2 external repositories, read-only repositories that represent sort of public repositories. One is called Nephio packages, one is called free 5GC packages. So we want to pick free 5GC packages, and then in there you will see there's 2. One is the operator, and one is the UPF. We need the operator first. And we say next. We can just say next on all of this. The defaults are fine. We can just say next, next, and confirm. Now what that's done is clone and create a draft package. So we have a concept of packages that aren't yet published. Packages can be published, or they can be in draft form, or they can be proposed for publishing. So they're not available to use in, like to do what we just did and clone to another repository, or to actually create a deployment out of, unless they have been published. So we don't need to make any changes to it. So we just need to propose it, and then we need to approve it. That's how we publish it.
Can you zoom it a little bit, or people on the back, they're probably not able to see it?
Is that a little better? I mean, if you follow on Zoom, you might be better off than trying to see it on this little screen. It's not that big. So now we can click, if we click on catalog here, we'll see that we have one published blueprint in our organizational thing. So now let's deploy it. It's part of it's our organizational thing. We can let's deploy it across multiple clusters. So if we go back to the dashboard, which is at the it says package management, or you can click over here. And we're going to say manage packages across clusters. So this is a UI screen to create a resource called the package deployment. What that contains is a reference to the package you want to deploy and a cluster selector that says, here are all the clusters I want to deploy it across. So we click add package deployment. Okay, we want to deploy an organizational blueprint across clusters from the catalog, and we only have one in there, so it comes up, it's right here. I click next. The cluster selector.
Hey, John, I think let's make sure that the people are at this page.
All right, we can pause for a second. Did anybody have success getting to the catalog, cloning their blueprint? All right, a couple of people.
How many people not at this stage and need us? Okay, So almost 4 or 5 people.
I don't.
Let's wait for a few minutes and get those people up to that stage.
It's this one that's presenting. I'm just on Zoom. All right, I'll give you guys a few minutes to get through to creating the catalog blueprint. If you go to the README, the steps are in there. You don't have to follow what I'm doing live. And I can come around and help too if anybody needs help.
Let's bring people to this stage and then we proceed forward.
Yeah.
So some of the repos are not being created. Only part of them have been created. I just need.
Oh, really?
Some of them.
They have a catalog repo not found.
Okay, if you're seeing repo not found, then let us know your VM name, host name, because we have a script that provisioned these all last night, but GitHub rate limits us, and maybe there were failures. Okay.
You want to tell me your VM? Mine is not here.
So we need your VM name. So we can.
Want to type it on Zoom?
Maybe you can use the list of other factories, those, the list, that way we can detect.
Yeah. I mean, if you guys can join Zoom.
Okay. No, you should be able to run the repos.sh, delete. Yeah, there's a command, repos.sh, no, not clean. Repos.sh, delete, and then the name. Oh, no, just
Post
create
the Zoom link.
just to create again.
There, it's coming. I can't.
Because part of it is created.
Sunny
What it does is
Okay.
Let me post it to you on.
Okay.
Okay, I can do that.
So
Post it on Slack.
if you actually go to, there's a link in the, I think the README or near the top or maybe in the logistics file. You can type your Nephio POC, if you're number 101. You can see you should have 4 repositories in there. If you don't, then you need to talk to Vish or me or somebody and we can recreate them. So this is, it's github.com/Nephio test, Nephio-test, and then click on the repositories and then type in your VM name in here. And if you don't see 4, then raise your hand. Okay. What's your VM name?
What's the number?
Yeah, for me it's 80.
80.
80.
So can we run it for, recreate it for? Yep.
Actually, yeah, just yell at it right now.
Yeah.
Anyone else?
Yep. Great question. So this is a kind of just.
Could you repeat the question?
Oh, I'm sorry. The question was, what's the difference between an organizational and a team blueprint? This is really just an opinionated UI, and this could change over time, or we can make it configurable. It's not right now because it's very prototypey. But the idea is that your larger organization may say, my platform team may say, here's the blessed version of this particular workload or application, and then you may have multiple teams. So a simple example would be a database, right? A database, and this is not network function related because a lot of this infrastructure is not just for Nephio, but if you had a Postgres instance, your platform team may say, here's our validated PostScript a package, it's got the right image, it's got certain policies about how much CPU or disk or whatever it can use, whatever you have, and then they publish it to the organizational blueprint. Then your different lines of business each have applications that make use of that Postgres thing. They would create team blueprints for their particular application that's derived from that organizational one and add in things for their particular team. And then their deployment across the 10 clusters would be based off their team one. You don't need to do the team one. You can skip it completely, right? It's just another layer which we've found some of our customers are interested in having. That's all.
Anybody having the repos not creating problem, please tell me.
Yeah.
Number?
Yeah, typically the sort of expected flow, and all of this is all up for discussion, and maybe it would be different in every organization. But the expected flow is an external one becomes an organizational one becomes a team one. And once you do that, it might take about a minute for the porch to recognize that repo is now working. You can, if you really want to see, if you've got a shell open, you can type this. So let me make this bigger. So in your VM, if you do kube control -f kube config ~.cube/nephio.config, that's saying I want to run a kube control command against the Nephio cluster. Remember, we have 4 clusters in here. Get repositories. If it says ready true, then that repository is properly available and accessible by the infrastructure, by Porch. So anybody else need their repos created, or do you want to go back and discuss the flow of how to create a catalog blueprint again? It is in the README too, if you want to go look there. Oh yeah, if somebody, we got our infinite, yeah.
That's a terrible picture.
So it looks like in this room we have taken care of repos. If anybody has issues where the repos are not getting created, let us know.
Question? No, I don't see anything on chat.
I don't know. Oh, there are no questions on chat? Okay.
All 19.
All 19 people are sleeping.
All 20 of them.
Yeah.
There's 4 on chat.
No, there's 4 questions on chat, it says here.
I don't see anything on chat.
Oh, because we're not organizers, probably. We can't.
No, really?
I don't know. That's that's my screen, supposedly.
Yeah, that's yours. So you should be able to open it up.
No, it's this machine.
Yeah, it's from your other machine. I see.
No, I've been on Zoom the whole time. It's on this machine. Because this is what's plugged in.
We can drag it around.
Can we see what?
I'm trying to get it over there.
Oh, I see. That's why I was confused.
Oh, there it is. This is harder than it looks.
Yeah.
Yeah, because it's not really monitored.
There it is.
Okay.
Rush to link. Could someone help produce echo?
It's just about the echo. Okay, and it looks like Victor has already been asking on Zoom whether there's any trouble. So I think we scared them all off.
I'll close this for now. Okay, there we go.
Right.
Okay, so have folks made it this far? So who's successfully created their catalog repo? Oh, sure, what's your question?
Hello. I think, yeah.
John.
Question?
Yes, sorry.
Yeah, I'm sorry. I'm just going ahead, and then it remains at the pod creating stage, right? And you have a comment there. It's because of some Multus configuration issue.
I'm sorry, it stays in what stage?
pod creating stage. It's in the wiki.
Oh, you've gone all the way ahead to the
yeah,
UPF.
yeah.
Oh,
So
wow. Look at you, man. You're way ahead.
No, I want to understand what is the Maltus issue there, kind of.
It's a issue of we were in a big hurry, and there were teams all over the world people all over the world working on this, and we discoordinated our configuration of our IPAM and our CNI types and our CNI master interfaces with what's actually on the cluster with what we have in our configuration. Now this is actually pretty cool because this is exactly the problem that won't happen once the infrastructure is also managed by Nephio, because it would already know that information. We wouldn't have to coordinate. It would just do it. But we're not there yet.
So not a technical problem.
Not a technical problem. It's a
Okay. because
it's a ran out of time problem.
Yeah. Okay. Because we use Maltus and we didn't have any issue. So I want to understand, is there any specific with Maltus issue kind of?
Now this is just setup issue.
Okay. Thank you.
But that's great. I'm glad you were able to get that far ahead. Are people? Does anybody need help before I continue? Or all right, let's move forward. Hopefully, people are along. So, the first thing, like if we'll go back, we created an organizational version of our blueprint, our free 5GC operator blueprint. And now what we want to do is deploy that to the edge clusters, because that's where we want to run our UPFs. So I'll start over. We go to the dashboard, to the main page here. And by the way, this is embedded in this Backstage thing. Backstage is Spotify's sort of infrastructure UI pluggable framework, and that's where we built our UI to sort of bootstrap us quickly. But so that's why this is all weird, and none of these mean anything, and the only thing that matters is this one link that says Nephio on the side. So anyway, you go to this screen, manage packages across clusters, and we're going to add this package deployment. Okay. We're going to select the organizational blueprint, the catalog, and the free 5GC operator. Now, we want to do this. We have 3 clusters registered with Nephio, a regional cluster and 2 edge clusters. They're all in US Central 1. That's the region that's defined on them, so that's why that's the only thing that shows up. We want to leave the site blank because we don't want to deploy this to a single site. We want to deploy it to a set of sites. So we want to deploy to the edge sites, not the regional site. All right, we can leave all that the same, and then we can create the package deployment. So what's going to happen here is this resource will get created in the cluster. The package deployment controller will see that resource, and it will make 2 clones of the catalog blueprint and put them in the edge repositories, 1 for each edge cluster. So what we see now are 2 deployments. Now they're in draft state. It creates them in a draft state. So we have to go through and publish them. We're not going to actually make any changes to them. So we're just going to click on them. If you want to explore it, you can. You can look at what this operator package looks like. But for now, we'll do more of that later. So let's just propose and approve. That's the first one. So we're manually proposing and approving. But of course, it's all Kubernetes resources under the hood. So we could actually build an automation that runs the package through various gates and validations and automatically proposes and approves, or multiple controllers to do that. But this is what we do for now. That was edge 1 I did. So if we go back and we visit edge 2, we see this one in draft state. We propose, and we approve. So I'll pause here for a moment. And how are things going? Do people, you can actually see, if you go to your CLI, you should now be able to see, one, you can see the package revision. So if we do the Nephio config, the package deployment, you can see there's a free 5GC operator package deployment. If you're curious what that looks like, you say -o YAML, and you'll see that it's it's the name we gave it. It's got a reference to that package, and then it's got a label selector for that edge. Now, what that resulted in is it resulted in what are called package revisions, but those are maybe too many to see, but you'll see them here. But what's more interesting is that it actually ends up with something on the edge cluster. So if we change the kube config we're using to edge-1, get namespaces, we see that there's now a free 5GC. Well, mine has been, I've gone through this 10 times, so it's 18 hours old. But yours should say it was just created. And we can say get pods, and you can see, you should see a running pod that looks something like that. So that means that we went through this whole flow of we submitted a package deployment resource to the management cluster. A controller picked it up, created 2 new package revisions, 1 for each edge cluster. We approved those, and then the config sync, the git syncer running in the edge cluster, pulled that package down and applied it to the cluster. So now we have a running free 5GC operator across all of our edge clusters. So that's our first little journey, and that's the first thing we need to do in order to actually deploy a UPF, because we're using that operator to manage the UPF. How are things coming? Do people need help? Yes. Yes. So the command, this is the command that's going to show you that the pod is running of the operator. It's kube control --kube config ~/.cube edge-1.config. So this is telling it talk to the edge-1 cluster, because we've got the 4 clusters on here. Look in the free 5GC namespace for a pod. And by the way, well, I probably should have put more commands, but at the bottom of the README, there's some troubleshooting commands, but I don't think this is in that list, so that would be helpful in the README. Yes? We've deployed 2 operators which will manage the UPFs once we deploy a UPF. We haven't deployed a UPF yet. Right, exactly. Okay. Our next step, let's go here. So what we've done is we did this. We created an organizational version of the free 5GC operator package. We deployed that across the edge clusters. So those are detailed here if you want to try that. I mean, if you haven't gotten that far, you can look at that to see how that's done. The next thing we're going to do is deploy this thing we call a 5G core topology. So the idea here is that, and I'll show what the resource looks like. The idea here is that we want Nephio, and we want to build controllers. This would be one of the Nephio CRDs and controllers, and it would understand that there are these multiple functions. Part of what we want is to stop managing these elements like individually, but to be able to manage them as a set, because they're interrelated. And when one changes, you may need to change another one. So if you've got a bunch of UPFs talking to an SMF, and you add another 100 UPFs, maybe you need to resize your SMF. Right? So that's a change in one set of configuration of one workload that implies a change is needed in a different workload. So in order to build that kind of intelligence into Nephio, we need to define CRDs that represent these sort of typical matchings of different network functions. So this is an area where we really need help from SIG1 and from the telcos and to understand the vendors to understand how the different architectures that people use to deploy these different network functions, and so that we can try to capture that in these CRDs and these controllers such that the typical patterns can be automated. But for now, this is sort of just a rough draft prototype of what we might do here. Right now, it only supports UPF. We were hope to get SMF, but time got away from us. But the idea is that you define a sort of set of configuration of a UPF in this resource that is invariant across the clusters you want to deploy it on. So if I want a particular UPF with a particular amount of capacity, and I want it to be the free 5GC UPF, and I want that configuration I want to attach to these certain networks, and that's what I want. And those networks, like the addressing may change from cluster to cluster, but there's a sort of name for those networks. That set of configuration that's invariant across the clusters goes into this resource. And then when we put this resource into the cluster, the controller will pick it up, and it will use that information to generate individual packages for each cluster, but it will allow it will inject, we call it injecting, the information that's cluster specific into those individual variants. So the invariant part stays in this resource, this resource gets used to generate the package configuration. At the same time, we pull information from other places. We pull information from the context of the cluster. So in this setup, each edge cluster has what we call a cluster context resource associated with it that defines its site code and defines the Multis CNI type that's installed on that cluster and the Multis CNI master interface that's on that cluster. That's not really a realistic model, but it works for our demonstration purposes. So we'll have a better model in the future. But what that means is that, so between those two clusters we have, they'll have different site codes, and they may have different CNI configurations. That information would get injected into the individual variant package for that particular cluster. We'll see this in a minute. Furthermore, you'll notice there's no IP addresses anywhere in here, because IP addresses vary across the clusters. What doesn't vary is the networks we want to attach, the names of the networks we want to attach the different interfaces to. So that's what goes in here. And we have another controller that runs after we create that draft package that will, there's a sort of placeholder in that draft package that says, I need a UPF configuration. We have another controller that comes in, sees that, renders the UPF deployment resource, which is what the operator will eventually consume. But even at that point, that doesn't know what the IP addresses are. So it says, oh, in order to fully complete this, I need to do some IP allocations. So it renders IPAM allocation request resources. And I know I'm talking this through now. We're going to actually see it, so it'll become more concrete. But I'm trying to give the overview. And we have also a diagram that gives the overview. So then then the IPAM controller comes in, sees those, allocates IP addresses, injects the IP addresses, and now we're finally in a state where it's complete enough. Actually, there's another thing that generates network attached definitions, and we can deliver to the cluster. So that's kind of the high level view. To actually do this now, what you need to do is go to this page, and over here, there's a little thing. You say copy, and then in your workshop VM, cat, and then a greater than sign, so redirect to a file, topo.yaml, hit enter, and paste. And hit enter again, and then Control D. So if we do that, you should have a file called topo.yaml on your VM that's got the content of that. And then you want to, right here is the command you would use to apply that to your cluster. And it should say 5G core topology sample created. I'll pause here for a minute. That was a lot to digest. And let's see, do people need help? Has anybody managed to make this happen? All right. We got Am, we got Wim. I know the gentleman in the back did it all. Oh, wait, we got a few people. All right. Do people need more time? Why don't we give it another couple minutes while we do it, and then I'll wait. I'll wait and continue. If anybody needs more time, raise your hand. If you've given up and you're just listening, then that's fine too. Yes, sir.
I'm a bit confused. It's like the user perspective. So from the user perspective, now we are using kubectl commands. So you assume like you have API access to the clusters. For part of the workshop, we didn't go that route. So
No. I mean, if we had had time, we would have built a UI screen for this too.
okay. So
We just don't have time.
okay.
Right. So this is all prototype. It's all in development. Yeah, I should have said that up front. Like, the kube control commands are for your debugging because the UI is limited, right? It's a very prototype type of thing. And we managed to build a screen. So Chris, the UI is all done by one person, Chris Fry, who's on my team at Google, and he's just like slammed out a bunch of this stuff really fast. But you know, there's only so much he can do. He's not magic. Yeah, I think it looks pretty good. It looks pretty good. Yeah, but I appreciate that question. So anybody need help before we continue, or shall I move on? Oh, how did it work for me? Oh, the wiki. Yeah, somebody can fix that. The wiki's editable by anybody in the world. The GitHub's not editable, but the wiki's editable. Is it in the, is this one, I just used this one. This one's got the E here. Is it one of these up here that was?
Yeah. That one, yes. Go down. The one below.
I just copied and pasted that. It worked for me.
Someone fix it.
Someone fixed it.
No, that one's not editable. I have to merge the pull request for that.
Yeah, I know. Someone has to merge the four requests. Well, I mean, you did here.
I'm not sure what, maybe people copied it from somewhere else. I wouldn't be the least bit surprised if I made a typo.
No, I just copied it. Oh, okay. The one below that, actually.
Oh,
Go down.
oh, this one down here for edge 1. Oh, yeah, look at that. Yes, that's a typo. If when you get that far, I don't know. I mean, somebody can submit a PR now if you want, but and I can merge it. But that's too bad. Yeah, this one below the picture. Okay. Yes, sir.
Might be good to wrap up. We're a little bit into the lunch break, so everybody's got to go get their own.
Yeah. So we started about 25 minutes late, which we already had more content than I could fit. I'm sure people want to get lunch. Why don't I try to wrap up this section, and then I'm happy to work with folks offline or whatever. We can, I don't know what the schedule looks like, whether there'll be more time to continue, but at least let me get through this piece, maybe another 5 minutes or so. Okay, then I won't pause, and I'll just talk through it. So once you've created that, you should be able to see, we have a read-only screen for this. We don't have a create screen, but we have a read-only screen for this. And what it does is actually create, it creates a package deployment under the hood. That package deployment then creates two draft packages. And if we click on one, now since I was talking and waiting, actually all these conditions got resolved. When you do it yourself, you'll see a badge on this condition if you come here really fast that says 1. And then you'll see that this resource is true, the cluster context. At the time of fan-out, the package deployment controller injected the cluster context in the new package. But this one will show as false and red, and it'll just say that it couldn't find it. Another controller will see that, it will pick that up, and it will actually resolve this to true, but it'll create a bunch more resources, and those will all be red. The IPAM controller will come in, we'll go look at what these look like. So what do these look like? So the UPF IP allocation request looks like this. So it's saying, I want to allocate from this particular VPC or sort of layer 3 address space for this particular network. I want to allocate a network IP /32, and so and a gateway. So it went out and it did it, and it stored that actual value back in the status. This is edge 1-N3. Let's go look at edge 2-N3. It should be different. Again, it creates them all in draft state, edge 2 and 3. All these ones that say added, these were all added by our automation controllers. Yeah, so this is the .3. This is the other one was a .2. So the other thing then, yeah, so that went and did that. And then there's another thing, which is this function that generates these network attachment definitions, which is the CNI configuration specifically needed for this interface. So none of these things were in the original package. That's why it says added. So the difference here is between what was in the original package that we provided to the package deployment controller, and then our other controllers came in later and made all of these changes. They created this UPF deployment resource. This is what the operator will actually use to generate the deployment and config map on the workload cluster. And they generated these network attachment devices. This little gear here means that it's a local config. That means it's only used to manage internally in the package all of these allocations and edits and modifications that we're doing. It won't actually be delivered to the end cluster in the end. So the only things that will be delivered to the end cluster is this. This came from our original package. It's just something for the free 5GC operator. This is our vendor neutral UPF deployment resource, and a namespace and the network attachment definitions. So let's publish this. Oh, this is just a bug. It's a multi-threading bug. We just need to refresh the page. Basically, it means something else changed the package under the hood while we were mucking around. All right. So that's published on Edge 2. We'll go publish it on Edge 1, 2. And then what we see, so we should be able to go back to the README. This is where the typo is. But fix the typo. And what we see is that the UPF deployment that was in the package has been delivered. The config map, the operator picked up that, generated out of it a config map and a deployment. And then, as I said, the container, it's going to be stuck in container creating. But it's pretty close. So to kind of wrap it up, the next journey here, if you want to go through it on your own, is the shift left style, which doesn't use an operator. It just directly renders the Kubernetes resources needed on the management side in your cluster. And there's a diagram here that thank you to Wim for this beautiful diagram, that explains how the controllers take information from different places and inject it into the package just where it's needed. So to kind of put that in the context that Sana talked about earlier, if you've got a network function, some network functions have 50 different microservices. Each of those 50 microservices has a values file with 50 or more values in it. So now you're talking 250, and then you've got 10,000 different instances of that. So now you're talking 2.5 million, right? Different values you have to manage, most of which are duplicates and repeats, but it's hard to know which one's where. So instead, we can build a model such that we associate those values with the model. So the cluster context contains things that are unique to that cluster that will eventually be fed into those, the equivalent of the values file, into the packages. The IPAM system, or the UPF record, contains that invariant piece, and then the IPAM system itself manages the individual IP addresses and can inject them at the right time in the right place. So we no longer need to upfront understand 1 million values across 10,000 clusters, but we can actually store them once, have that part of your organization manage that configuration with in its own way, but have a system that allows these pieces to cooperatively and interactively kind of inject the right config in the right place. So that's my time. Obviously, we didn't get through everything, but we're going to continue. We're going to make this a downloadable or at least instantiatable in your own cloud environment, and further refine the READMEs. So, but anyway, happy to talk to anybody afterwards about any questions. But thank you.
So John, for this question, John, how long will the VMs be available for people who wants to just pay them?
So 135 VMs for a day is about $1,500. We didn't give the Linux Foundation that much money for the year, so I don't want to leave them running too long, but we can leave them for another hour or two. What do you think, Condon? Yeah. Okay.
24 hours till the evening?
Till the evening is fine, I think.
Okay.
Just leave it until 4 or 5 p.m.
Yep, and then we'll turn down.
Just wanted to give that guidance to
Yeah, appreciate that.
Thank you.
And just the scripts and everything is available in...
Yeah, everything. So everything's in GitHub. There should be links from that README, or you can ask on Slack or any of us here. But everything should be there on GitHub. If you didn't deploy the free 5GC operator, then the CRD will be missing. If you deployed the operator, it should be there. But it's all prototype code. Things go wrong.
All right. So thank you very much, and I think the community.